Wow, it's actually working now. Okay. 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 Wow. Okay, hold on. I'm just setting everything up. I'm struggling with making this work for the last couple hours, so now that it's actually working, I have to actually do something. Okay. All right, so my name is Juno. I am an industrial designer who's been designing wheels professionally for like close to a decade, and then I also design various child-resistant packaging things and have done some like web design and other design things. Starting a little stream here to just show everyone my process designing stuff. And hopefully kind of turn it into like a little maker's space design stream with some occasional gaming possibly. This first week I'm just going to be working on some wheels for a friend who is hoping to sell 3 different sets of wheels, like 3 different wheel designs to clients or to customers. And he gave me permission to work on these on stream, so you guys get to do this with me and maybe even take part in some of the design decisions that will go into making these wheels. Bear with me as I'm kind of just figuring out the streaming thing, getting used to being in front of a camera, getting used to using OBS and all the other annoying little things I have to figure out for streaming. Hopefully things will go smoothly, and hopefully people will come see what I'm doing and stick around. I'll try to explain as much as I can. This first design, especially since I just started and so there won't be a lot of people watching. This first design, as you can see, is like already pretty fleshed out. I will just be doing some updates as per the customer or the client's request. And then the next 2 wheel designs in this series, I'll start from scratch and explain like the basics of where I got these, or how I created the models for the hoops, and even like kind of the basics of 3-piece wheels and the manufacturing process of billet or forged or multi-piece wheels, whatever you want to call them. These are going to be designed for CNC machining and will be produced in California at a facility. And I can go into that later down the line, but at the moment we're just making things that look cool. I'll try to, yeah, once I make the next one, I'll explain more of like how I know how large to make these, the kind of manufacturing constraints, center cap mounting constraints, and like how to make them actually attach to a car and not run into like your brakes or strut towers, the fender lip and all that stuff. Yeah, but right now just kind of working on this current design. Customer wanted me to work on this outer area and make it kind of flow better with this step in the outer lip, and then or possibly come out over that to kind of overhang on this lip here. But at the moment I'm just going to be kind of cleaning some stuff up here. Setting all this stuff up was easy. It wasn't that easy, but now that I'm actually like on the stream and doing stuff, it's like, what am I doing? What is design? What are wheels? Okay. At the moment, I'm kind of just cleaning up this feature tree a bit so I'm working on a file that doesn't have any errors. It looks like last time I was working on this, I was kind of rushing through stuff. So some of it was a little messed up. Where's the error? Gosh, this software is... I updated Solidworks to the new version and like... was kind of hoping that it would be better, because it's a bit shit. Just always finding ways of screwing things up and just making things annoying. Oh, that's a little error. Oh, there we go. All right. So it's SolidWorks. You're working on planes for everything. Gosh, here, let me heat up my coffee. Sorry. We're back. We're so back. We're so fucking back. Wait, can I say fucking on here? I don't know. Alright, hot coffee. So the basics in Solidworks is like everything is based off of these planes. So we have front plane, top plane, side plane, or right plane. And everything starts with just sketching on those planes and is just extruded from those planes or cut from those planes. It's very different from like Blender or 3ds Max or Maya or Cinema 4D, where those programs work with meshes and are much better for creating stuff for video games and stuff, because it can make clean, simple meshes that can be rendered in like a video game environment or for animations and stuff. Whereas this is not a mesh, this is just sketches off of a plane. It's kind of like a kind of convoluted, but it's similar to like the vector versus raster thing, where a raster is like pixels and a vector is like math. And so it can be expanded out and back in and still have the same like perfect curve, because this isn't like a mesh. This is like, there's like math saying that the radius of this curve is something. And so even if it's like a mile wide, it's still gonna be a perfect curve, because it's based off of those equations. But also like everything is constrained by values like millimeters and inches and stuff. So depending on where you're working, unfortunately, manufacturing in the US, where I am in, uses imperial measurements, even in machining. So I'm kind of forced to do stuff in inches, even though doing it in millimeters would be considerably easier. But we'll kind of go through, we'll just go through how this is made. So at its base form, this is a piece of billet. This is a chunk of aluminum that was put in a 10,000 ton press. Giant industrial machine that superheats the metal or heats the metal up and then compresses it into this shape using 10,000 tons of pressure. And so that shrinks the molecular structure of the metal, of the aluminum, and makes it stronger than like just a regular chunk of basic aluminum. And so when you see like 6061 forged aluminum, 6061 is the specific alloy. So that's like the percentages of different types of metal in the aluminum, because it's not just pure 100% aluminum. There are like additives in there, and like I'll have to look up exactly what those are, but like it just makes it stronger or more resistant to like water, and aluminum doesn't rust. It God, I'm blanking, but yeah, makes it degrade, and it makes it stronger. And then once you forge that, then that becomes even stronger, because it's shrinking the molecular structure down into a tighter structure. But so then we have this billet of aluminum, and this was created using this sketch. So this is from the manufacturing facility that is making these wheels eventually. So this is just a cross section of that. And then in order to fit inside the lips and barrels, or hoops as people in the industry usually call them. So in order to fit inside the hoops, which is like the front and back lip that the tire actually mounts to, these are 18-inch wheels with a stepped lip, and so that outer diameter is 16.4 inches. And so this is that. So I'm just simplifying the file so that I'm starting with the right outer diameter. And then these are some extra sketches just about that I pulled from a wheel that I previously manufactured that shows like how the center area needs to be for mounting of the center cap, and then the lug holes as well. But so we've got that. We just did that sketch, revolved it. Now we have this. And then I like to kind of get a general profile, let's say, side profile of the wheel. And so I have this. And so basic form, boom, there's that profile. And then I kind of started sketching out the wheels, the wheel design. And so this client wants the spokes to be shaped like hearts. And, or sorry, that was the previous one I did. To be shaped like stars. He had previously had a set of wheels that I designed where the spokes were shaped like hearts. And he wanted a similar design to those, but stars instead of hearts. And so there, and I decided the easiest way to get these star shapes in like a aesthetic way would be to create them separately. So this is like going to be done a little bit different than I do a lot of the wheels that I do, but I like to I don't like the cuts. I guess I don't like the spokes to be cut just like straight cuts down through, like so that the walls of the spokes are just like this. I feel like that is really basic and it leaves a lot of room for like visual interest and like coolness, let's say. And so instead we're going with a lot like a angled edges. What is the draft? I guess you could say they're drafted outwards. And so this is that basic star shape that I made. And we're gonna cut then we cut the center of the star out. And then that original kind of billet piece, all I needed from that is that outer ring, which is where the wheel mounts to the hoops. And so I cut out the center of that. But I still want this star-shaped spoke to follow that outer profile. So this revolved cut here is basically a copy of that sketch, of that initial profile sketch that I showed you earlier. And then we're cutting out the star. And so now you can see, and then we're going to get rid of those little bits on the outside, but now you can see that this this star is already starting to look like a spoke. And when we copy them around, boom, there, now we have 5 star-shaped spokes. So we're getting into it. Let's see. But we still need a center point where the wheel mounts to the car, because we need those lugs, and we need it to mount to the car. You can see on the right here, I'm just kind of have this up as just an example. This is the last wheel design I did for a friend here in Denver, and they finally came in the other day, and I went over there and we just kind of did a test fit on the car. You can see that the wheels are still wrapped in the protective film and they don't have tires on it, but we wanted to make sure that they lined up nicely with the brakes, didn't hit anything, and thank goodness they didn't. They all fit, and so everyone's happy. And then here, once he gets tires and stuff, we'll go over there and get some pictures of the wheels actually on the car. But I figured I'd just keep this up on the side of my stream just to show you a real world example of something I've designed in this same manner. And you can see that it needs that center area where the lugs mount. And so we're just adding in essentially just a little cylinder in the center. Now just combining it into one piece. Here's one of the lug holes. And this has to be this like angle there has to be a specific angle because there's like a standardized pitch for lug nuts so that you can get whatever set of wheels you want, and the lug nut, as long as they're the right bolt pattern, they get held onto your car and they don't fall off your car or rattle. And then just working on making it look a little bit more interesting, and then cutting out this shape here. And so this shape is a standard, like this has to be this way, so that center cap, you can see on the right here, this gold piece with a little carbon fiber bit in the center, so that snaps in. The center cap has a little rubber gasket, and then when you snap it in, the rubber gasket will go past this corner right here, and it will hold the center cap into the wheel and keep it in there even when you're driving on a racetrack or on the highway. And so the wheel needs that exact shape. And then I wanted it to not be just a cylinder around the center there. Just because, yeah, you can see that's just kind of ugly. You just want to address like every part of the wheel you can and just make sure it looks good. You don't want it to be too busy, but you want to make sure you're thinking about every little part of it as you're doing it, so that you have a thoughtful design at the end. And then once I had this basic wheel here, you could see like if this was made, it would bolt to a car. The center cap would attach to it. But it has really hard edges and corners, and nothing in real life is ever a perfect corner. Even if you just mill the top and the side of a piece, like that edge will be sharp, yes, but like when you start zooming in, it's gonna be rough. It's gonna not be just like a perfect line like it is on the computer. And so you want to control every one of those corners. And every one of these edges needs to be controlled by you, because if you don't control it, then the machinist will, or it will get like so let's say this, I just send this in. The tool that they use to cut these out is essentially a really fancy drill bit in a CNC machine. Depending on the diameter of that tool, it's going to just round these edges no matter what. So if you don't tell them, I mean, one, they're just going to be like, we can't make that. But like, if I sent this thing and it was like, make this, I would essentially be like leaving those choices up to the machinist. And I want those choices to be mine. I want all of these edges and corners to be my choice. And the easiest way to do that I've found is to then cut the wheel into one spoke. And then just kind of repeat it back around into 5. And that's just essentially doing 1/5 the work. So why not? Oh gosh, all this talking is gonna be rough. Okay. See where we went next. Okay, so I end up doing stuff in some kind of like weird roundabout ways sometimes. I'm trying to get better at like doing things better and like more with less steps, and making this feature tree in the side more simple. But at this moment, we're just gonna make it look cool. That's the goal. Oh, shoot. Okay, so first thing we do is we do some fillets. Fillets is, I guess, like a manufacturing term for rounding a corner or rounding an edge. And so you can see I made this large fillet at the bottom, bringing the spoke into the center hub area. And this is visually looks better, but also it's stronger that way because that nice big sloping curve is going to distribute weight around better than if it was a tight little corner, because that's going to create like a weak spot later on. And at some point in this stream, I'll show like the actual stress testing, because like in Solidworks or Fusion 360 or any of these pieces of software, they usually have some sort of like FEA, which is finite element analysis testing or simulation capability. And that's basically where you choose materials. So I'd choose 6061 aluminum, and I'd choose all the materials, and I would then exert forces or simulate forces being exerted on the wheel to figure out where the weak points in the wheel are before it's even made. And so like these wheels on the right here, before I sent them for manufacturing, I tested the wheel to make sure that the assumptions that I had made on like, okay, these spokes have these nice I-beam shape and this thickness and this blah, 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 they're going to be strong. And like, yeah, I can probably guess at it, but it's much better to do these simulations so that at least you have a simulated confirmation that your assumptions on strength and design were correct. And then I'm still going down this feature tree on stuff that I've already done. And just kind of explaining my way down the tree. This thing on the left is called the feature tree, and it's just a history of things I've done, which is probably it's the best part about SolidWorks is like having a visual record of everything you did. And you could even delete stuff out of it in the middle of it. It might cause a lot of problems, but you can move things around in the feature tree. You can go back and edit one part and then bring the tree forward and see what happens. But it means that like everything you've done is reversible and changeable, and it's not like in Photoshop if you like blur a section of an image and save it and then open that again, you can't get those pixels back from you blurring that. Whereas in this, if I want to then go back and change this thing, or even the diameter of the wheel or the bolt pattern, I can go back and just open the file at any time. So that's pretty sweet. Yeah, so this kind of just fleshing out the actual design. And like I said, you can't have any sharp corners, and you really don't want any like sharp corners on wheels, because I mean, yeah, it might look cool in some setting, but imagine like you or the person you're paying to mount the tires on the wheels, like imagine they're grabbing your wheel and then they just like slice their hand on a sharp edge on the wheel. Also, like once they go into like the finishing of the wheel, they're gonna get, all the edges are gonna get blunted in like the polishing and surface finishing stages. So like nothing's ever gonna be like blade sharp anyways. But these rounded corners are stronger because like if you bump it on something, like if it goes to a point, that little point is gonna chip off. It's like if you have a kitchen knife and you like bang a kitchen knife on the edge of a counter, like you're gonna chip that thing. But if you take that same kitchen knife and you bang the back side of it on that, like it's probably not gonna do anything because it's thicker basically. So it's stronger. It's just everything needs to be rounded at a certain point. And like this looks like a big like lumpy rounded thing, but that's a quarter, it's like a less than a quarter inch of like a radius. So like that's, you know, really tiny. So it's not like that rounded. Anyways, so you can see all of these are fillets. This entire part of this feature tree is just rounding stuff off. And now you can see that these forms are starting to flow into each other. And you can even take off the corners and you can see like these nice rounded edges are gonna reflect light in a much nicer way than like if it was just a bunch of sharp edges anyways. And then we're gonna just copy and radial repeat that all the way back around. Put that final like top edge fillet on there. And then there. And then the last step for me on the wheels is this back pocketing, it's called. And it's not necessary, but it's gonna make the wheels lighter. And even if you're, you know, not driving a race car, you want your wheels to be as light as possible just for making them easier to take on and off your car. But also like in a technical sense, any sort of spinning weight is the most important thing to reduce. Because like as your wheels are spinning and like gravitational forces are pulling outwards, it's going to kind of be heavier. I mean, I'm not an engineer and I'm not great with physics, but essentially the light, like heavier wheel, there's going to be more, it's going to be better than like, oh, this is a pound lighter. Once those wheels are spinning and you're turning the car around like a track or something, even just a couple pounds lighter wheels translates to easier steering and a more nimble car. But yeah, I mean, obviously these aren't going on a race car though. It's not the most, it's a form before function design, that's for sure. Oh God, I love caffeine. Let's see, so, gosh, now that I explained all that, what are we even doing here? Huh. I guess we could just go into I mean, we can go into like the next steps and stuff, and then I will have a better plan for like changing the design and stuff for the next stream. But I think for this one, it's just mostly me just figuring out how the technical aspect of streaming to Twitch and YouTube at the same time, setting up all the devices and everything. It's better. Yeah. Yep. What am I saying? Okay. All right. So let's go back to the full assembly, and you can see here we got the front hoop or the lip and the rear hoop or the barrel. A lot of people will call them lips and barrels. The lip is the lip of the wheel that you can see, and the barrel is the one in the back. It's usually larger, but yeah. So we've got those. This is an 8.5 by 10 inch wheel with a 3.5 inch lip. And then we've got our center cap, which, oh gosh, all right. Yeah, you can see right here, this is the little notch for the O-ring that's gonna hold this thing in. And you can see it sits right against, so this sits flush against there, and then the O-ring pushes, as you're pushing it in, pushes past down this slope and then pops past this edge. Boom. And now that center cap is stuck in there, and if you want to get it out, you can, but it's not going to come out while you're driving. And we've got our wheel face. The only thing missing from this assembly would be like the wheel hardware. You can see all the bolt holes for said hardware, and the standard is 40 bolts to hold it together. You can see on the right side here on this wheel, we've got 10 bolts visible, but that doesn't mean this wheel's only held together by 10 bolts. The other 30 bolts are just screwed in from the back instead of from the front. But this was kind of just a visual choice. We wanted to have these 10 bolts exposed on the outside. Yeah, so we've got that. So we'll export this thing, and I'm just gonna temporarily put stuff in here. I am gonna have things better organized in the future, but at the moment, this is how we're gonna do it. And then the fun part, and this is going to be another kind of testing for the stream thing, just to see how well my computer can handle doing all this stuff at the same time. We're gonna do some renders to see what these things could look like if they were machined. So I exported file from Solidworks, from the 3D CAD software. And now we're bringing it in to Keyshot, which is the rendering software. And I'm actually gonna... Oh, look, there it is. Woo. I'm actually going to bring up the task managers so I can monitor on the other screen what this is doing to my computer, essentially. Because rendering software is especially intensive on your computer. And that's because it is using as much of the GPU as it can possibly use, as the computer will let it, to render light. And so at its core, I mean, you choose materials and then you choose where light's coming from, and then the software, because like anything you see in the world is essentially light reflecting off objects going into your eyes. And so this simulates that. And so it's just rendering light bouncing off of the material depending on the parameters of said material. Okay, so on the left here, we got all the materials. We got basic ones. It's from all different types of metal, plastic, yada yada. And then we've got some stuff that I made myself that I use for a lot of things. I'll just put some base stuff on there. I like to, if you can't tell, but these wheels on the right are done this way. But the standard right now, I suppose you could say, or like the nice way to do it these days, is to powder coat the rear hoop or the barrel black. And this helps, like when you've got tires on it and it's on your car, it helps just kind of make it less distracting when someone's looking at your wheels. Because like if that was chrome, there'd be all these reflections of the back of your hub, your brake caliper. You could see all the brake dust and crap and schmutz from driving on that. Whereas if this is like in a satin or like non-gloss black like this, it's gonna hide a lot of that, and it's just gonna look better. It's gonna be better. And so this is a nice satin black color that I made. That is pretty similar to what it would be like in real life. And then a lot of people will want this outer lip chrome, and they kind of come like that from the start, which is because they're made by spinning metal and spinning it around, or let's see. So it's kind of either like a disc that what I think is like it's a disc, and then they spin it really fast and they pull it into shape like with a tool. Anyways, but they come polished usually. And that looks really nice. It's very, very classic, like old Ferraris, old race cars. They came with wheels that looked like that. So it's a very classic look. And it looks expensive, and they are expensive, so Boom. So we've got chrome, or not chrome, but polished. And I'm just gonna adjust the settings just to make it look a little better visually. This is the amount of ray bounces that it's processing, and that directly corresponds to how good the render's gonna look. All right, and from there we go to the fun parts. You can see on the right here, these center caps are this nice metallic gold that matches a lot of the other parts on this person's car. The manufacturing facility did an amazing job matching the gold. Honestly, that looks phenomenal. So we're just gonna make that material. You can see all these kind of basic materials in here. Amber. All right. So let's bring down the metal roughness, make that more shiny to match the image on the right. Be a slightly redder shade, I think. Yeah, look at that. Ain't that nice? Very metallic, so let's bring that up. And honestly, that's already looking pretty damn good. Alright, cool. So that looks about right. Okay. And then the cool thing about Keyshot versus like other rendering software such as Blender and Octane and stuff, those pieces of software are going to be much more advanced than this, and I am in the process of learning some of that stuff, so hopefully I can integrate that into future streams. But this is great because it comes with all these materials already defined, and you can kind of just drag and drop. Whereas in these other more complex things, you have to create every one of these textures. And so like, boom, there we go, bam. See, carbon fiber, just drag and drop. Look at that. And then we're gonna just have white text on there, and then just choose a kind of gray for that circlip. You can see on the right the actual clip. It's kind of like a black coated metal. But yeah. Okay. And then the fun part is actually choosing a finish for the face of the wheel. What do we want? What is that? That's rose gold. I would have such a hard time choosing like wheels for myself to be honest, like, because I have like all this freedom to like test it out. Yeah, I would have issues. I do kind of just like just metallic silver. And then, so like, okay, we've got our basic wheel, but this is like a really boring scene here. So we're gonna kind of doll it up a little bit. You can see already facing the wheel up towards the lights has done a lot just for how the wheel looks. Got these nice big reflections. Looks nice. But still boring because like the background's essentially the same color as the foreground. And that's kind of lame. And also I'm making use of just the lighting environment that like just starts when you open the software. And so that's also kind of lame and boring. So we're gonna just create our own lights. So I just brought in a spotlight. We're just gonna put that there, and we're gonna turn the brightness of the background to 0 so that we're gonna make all of the lights. And you can see already like the drama of just this one spotlight above here. That's cool. But let's see. But we want to do something a little different. Something a little bit more complicated. So rendering in this and creating the lighting environment is essentially like in a lighting photography studio. You just do it all the same way. So if we look up on Google, lighting studio setup images, you could see kind of this, how these people are lighting these professional studio lighting environments, and a lot of these are taking pictures of people, and that's going to be like a little different because that's all about making people look good, and you're worried about like dark shadows under the eyes and like how people's faces are going to look. But when you're like lighting a product, it's going to be different. So like this teddy bear, you can see the sheer amount of lights that are right here. But that's overkill, and also just doesn't look as dramatic or good. So let's do something. I like this where it's got like this colored back, like draped ramp. And then it looks like it's got two large lights to just kind of create the general lighting of the scene. And I should know the names of all this stuff, but I don't. And then there's this bright light back here that is generating that shadow. It's like, so we're gonna kind of try to make something like that. So let's bring our environment back in and get rid of our spotlight for now. First thing we're gonna do is we can bring in a ramp, like in in that scene, and that is a big ass ramp. Oh, there we go. That's better. All right, so we've got the ramp, we've got our wheel. But our wheel's just kind of floating there. I kind of want to make it look realistic. So we're gonna put one just lying on the ground like this. I do like how that one looked angled, so we're gonna duplicate that. And then we're gonna have one leaning against that. And there's no like physics or anything in Keyshot, and so you kind of just have to like visually line things up so they look real. So that's what I'm gonna do right now. See, that looks like that would fall. Boom. All right. The reason this looks grainy and kind of like fucky every time I start moving it is because every time you move something, it has to restart its rendering process. And so you can see in the top left, this like samples thing. As soon as I move, it goes to 1, and then it starts going again, and it starts cleaning up. Each of those samples is it's simulating that light. Oh, we're on CPU again. Oh, there we go. Sorry, I was cooking my CPU. I was using 98% of my CPU. So now we're using 88% of our GPU, 90% of the GPU. And I do have a 3090, which is pretty overkill for most video games, but you could see that like just me running this stream and Keyshot is maxing out, because again, like Keyshot will use all of the GPU or the CPU or whatever is available to it, so it will just max out your shit. And like doing a stream, you could so we're at here, I'm checking just to see if it kind of looks like if it's touching and looks like it's okay. So I don't know if this would fall or something in real life. I think possibly this would be fine. But cool, that's our scene, and maybe we'll put another one in there too. Kind of a little still life. Bruh. Alright, so we've got our wheel that's up there. And I don't know, maybe it looks silly. I don't really like that, actually. Let's just take that back out. I lied as a joke. Okay. So we got our backdrop ramp, and we'll kind of need to make sure that when our camera is looking at the wheels, we're not seeing that edge of that ramp. So we want to do it like this, and then we'll move our little arrangement around till we like. Sure, that's fine. So let's save that camera. Bam. Okay, so now you can see we've got our ramp like in the picture. And our scene here. But now we need the lights. And you can see these are like these big soft boxes. And so I think, which is basically just like a semi-translucent white, it's just like a white bed sheet with a light behind it. And that makes it so when the light hits it, it softens that light. So that you don't get like hard edges, hard reflections. So we're gonna do that by creating a disk. And that disk is going to be an emissive light. And then we'll start with white. Do slightly warm. Whatever. Boom. Alright, we got our disc. Alright, so it looks like we got one. At an angle. Over here, and it was definitely bigger than, it's pretty big. So we'll do one big one right there. That's kind of, and this is kind of like a light theory thing, or like a lighting theory thing, but I did one that's slightly warm light. And then this one is going to be a slightly cooler light. Okay, and this backdrop material is going to be red. It's boring. I'm a big fan of lilac as just a color. I don't know if it'd be ideal for this, but it is a color that I've used on my banner and stuff. So boom, we're gonna use lilac. And I'm gonna take the brightness down here. Okay. So we get those two big ass fucking light things, and they're kind of acting weird, to be honest. But boom, we got those. Not quite sure why it turned the... I'm still kind of learning how the lights work in this, but I think once we bring in the like spotlights, yeah, see there, now that purple is showing up. I wonder... Alright, we're just gonna experiment for 1 second. Emissive area light. Maybe that's what I should be using. Okay, there. So let's say 10,000 lumen. Bam. Shabam. Okay. 10,000. Boom. There we go. Look at that. So we got kind of the basic initial lighting environment, let's say. These are both like almost touching the ground, so let's put this one up. Let's move this one up a little bit too. Okay, so, and we don't want these visible to the camera. We can make them visible again if we want to mess with them, but I don't want to see them. I don't like it. All right, so then we go back into our spotlight. And it looks like we have one in this back corner on that picture. Alright, there's that. But I don't really like... There we go. I was like, I don't really like... How'd I do that? It's wider beam angle. Power. Okay. That's pretty cool, but right now we just have lighting coming from the back, and that's not really like the focus of this, like the back of the wheel. We want to see the front, so we're gonna make another light. Let's just kind of finish the old. Okay. Alright, cool. So we got two of those nice little shadows, but we need like a little kind of pop little light in the front. Maybe that's what it's called, a pop light. There's something to pop light. I don't know. Point light? What the fuck is a point light? I should know these things, huh? It's just literally lighting one point. Okay, we're not gonna do that. I don't like that. Spotlight. Bam. Alright, so now... Yeah. So now we got our light in the front. It's gonna illuminate the actual face of the wheel. And this could be kind of just like a general light. Boom. That's pretty cool. Pretty cool. I don't really like what's going on with the shadows, but I'm not really a professional studio photographer, so we'll work with this for now. So that looks pretty cool, pretty cool. I wonder if we just boost these up a bit. Boom. All right, so that's pretty cool. Where's our camera set to? That. All right, so and then let's choose a lens. So 50 millimeters is like the equivalent of your own eyes. It's like the kind of, I don't know, it's the way your eyes see stuff, the focal length, the perspective that you're used to seeing. But for studio photography, at least for studio portrait photography, 105 is like the classic portrait lens. It works well for human faces, makes them look the best. I don't really know about wheels, but let's go with a portrait lens, 105 millimeter. And like, I don't know, that looks pretty damn good. I like that. And then you can set other camera settings like depth of field or the f-stop if you're into cameras. And that is essentially the range, the distance range in which stuff is in focus. The smaller the number, the less is going to be in focus. You can see right here, like, I usually click the like center cap with my logo as like the focal point because it's my wheels and I'm advertising my company, so I want my logo to be in focus. And you can see like the focal distance, or like the focal distance is like, or the focal range. It's like only a matter of inches. And we want at least like the entire face of this front wheel to be in focus. So let's go up to like an f-stop of 3, see what that looks like. Boom. So this looks pretty good. You can see that wheel in the back is starting to go out of focus. And the very front edge closest to you or the viewer is also going out of focus. But the majority of the wheel is in focus. I like that because a lot of renders look unrealistic because everything's in focus. They're too sharp, and so they don't look like a photo. But having like the little blurred sections makes it look like a photo. Makes it look like an actual studio photo. Another way that we can kind of make this more realistic, and this is going to be a real test of streaming and multi-streaming and broadcasting and rendering all at the same time, but we're going to add a very subtle mist, essentially. Kind of, I guess this image kind of, you could see the kind of like, it looks like there's some sort of atmosphere in this picture. And like, yeah, you can see here, like, it's like you could tell that there are particles in the air. It's real air. You're there. Like, I don't know. And like renders don't usually have that because it's just there's nothing. There's just whatever objects you put in the scene. You have the lights and you have the object, and the lights, the software is processing how the light comes from the light and bounces off this. But we want to put some particles in between there to kind of make it look more real, make it look like real life. You're going to have to bear with me on this for a minute. We're going to add a cylinder big ass cylinder, just what you've always wanted. Boom, big ass cylinder. takes up everything. And we're gonna put a scattering medium on that, which is essentially just particles. Okay, so let's go back to our camera. Why does it keep turning off of the GPU? Just every time I look away. Yeah, boom. So now it's kind of hard to tell, but it looks, and like you might say that it's kind of looks worse, but you could tell that there's particles in the air. And that may be a bit excessive. Kind of a warm mist. A warm mist. Everyone likes a warm mist. Bam! That looks pretty good. And then we can kind of add some oh, sorry, I shouldn't be whistling on stream. I'm sure probably cuts most of it out. But, okay, so now we kind of can edit the photo before we take it, essentially. Or edit the render before we take it. So you can see I'm bringing up kind of like a curve histogram, like a photo editing software. That's pretty cool. That's pretty cool. It's linear. Let's start with that. Okay. So that looks pretty damn good. Alright, cool. I like that. I like that a lot. So this last step is to just do that final render. So we're gonna render that and just see what it looks like. And you could see as it's doing those samples. So I'm doing a total of 900 samples. So it's basically 900 like tests of how the light goes, or I guess 900 like instances of processing that light. And the more samples it does, the better this is gonna look. And you could see all these little fireflies, they're called. I'm not sure if you could see it on the stream, but all the little white kind of the noise, all that kind of gets taken off at the end. It's definitely like more present when I'm doing that kind of atmospheric kind of particle thing on the whole scene. And I think that's kind of just I guess like errors in it processing the light, essentially. But this has a nice denoise pass it does at the end that will get rid of all of those. So you may think it looks grainy, it looks weird now, but like once it gets to 100%, it will look better. So hopefully the stream looks good. Hopefully I can come back and like watch it. I don't know if Twitch or YouTube records the stream, so I'll have to see. But hopefully everything says 0% dropped frames in OBS, so that's good. I think this has been a really great test of streaming and the capabilities of me and how I've set up this stream, and like in my very inexperienced state of just looking at a bunch of YouTube tutorials and fumbling through OBS. I have managed to multi-stream to Twitch and YouTube, and I'll be continuing to do that in the future. This was just kind of like the first test stream, so I didn't like send out a signal on Instagram or tell anyone of my friends that I was started streaming. I just wanted to like sit here and talk to myself for a while, I guess. But I just wanted to do one stream and just see what happened. I'm not sure anyone dropped by, but that is to be expected. For being my first stream, why would someone come find me when there's 80 gajillion other people streaming? But hopefully in the future people will come hang out with me while I design wheels for the beginning. I've got this wheel design to finish, and I've got 2 other ones for this client. The next design is going to be a 3-spoke wheel. And I don't know about any of you guys, but 3-spoke wheels have always been a favorite of mine. There's just something about it that it's just cool. And so I'm excited to do those, and I'll do that entire design process on stream, start to finish, starting with that just initial forging and talking about manufacturing constraints and setting up the file, and then going into just designing and actually creating the wheel design. As you can see, bam, now none of those little dots are there. Everything is really smooth, and like this looks like a photo. Like if I wanted to make it look more realistic, I could add some like imperfections in this backdrop ramp. Would be a good start, because like in real life this would be made out of cloth or paper, and it's never gonna be absolutely perfectly smooth. You'd be able to see like fibers, little coloration differences, stuff like that, and like even as shiny and polished as you could get the wheels, there'd probably still be a little smudge, something like that somewhere. So just adding, if I wanted to go the extra mile to make this look like a photo, the real advanced rendering stuff is adding imperfections, which sounds ridiculous, but that's how really good renders achieve that photorealistic look, is they're not perfect. And at some point we'll go into doing that. We'll go into some more rendering in-depth stuff if people want to see that, because like I've been using this software for many years, and I don't know if people be interested in learning like how to set up these scenes, how to create materials, stuff like that. But I'm open to doing different stuff on the stream than maybe I had kind of planned out in the beginning. Like, I would love to teach people some of the stuff I know about some of these things, and if people want to learn about setting up rendering scenes and making materials, then we can go into that one day or a few days. And if people want to like learn how to set up the set up stuff within Solidworks or Fusion 360, we can use that. We can go into that. Or even just like the basics of how I found these people to construct these wheels in the first place. Like where I got these ones made and how long they took to get here, and how to reach out to manufacturing places and source actual products and stuff. Like we could go into that. But at the moment, my plan, I realize I'm just staring at my screen instead of at the camera. I should probably look at the camera more. But in the future, so this first week, I'm going to be working on wheels exclusively. But next I have a really cool project. I've got a couple of these like old vintage cameras, and I partnered with this company, which I'll talk more about that, and they sent me a development kit for it's a manual developer for Instax film. So Instax film is just Fujifilm's version of Polaroid. It's an instant photo, well, instant, but basically to develop those, it flashes an image onto the Polaroid, and then that white bar at the bottom is where the development chemicals are, and to develop it squeeges those across the thing, and then you get your picture. But this company sent me a manual kind of crank operated Instax development unit, and so I need to, from the ground up, design a piece that fits on the back of this camera so that I can use this to take Polaroids, essentially. Turn this into an instant camera. And this is a camera from like the 60s. Uses sheet film, so it's basically useless at the moment, unless you have a dark room and a lot of stuff. But we're going to turn this into an instant camera that like anyone could use. So we've got that. And then I have an Instax Mini, like battery-powered development unit that I've taken apart, and I'm hoping to attach that to the back of this camera, which is another vintage camera, slightly different. But again, film camera. But hopefully be able to turn both of these into an instant camera where anyone could just take it and take a photo. You get your Polaroid and then bam. So that's going to be on like the docket after the wheels, is some of these instant camera conversions on these vintage cameras. And that should take a little while. It's going to be a lot of engineering and testing and design and 3D printing. You can see the 3D printer back there. and yeah, it's gonna take a long time. So that'll be the next project after the wheels. We'll probably do more wheels throughout the stream because that is kind of my favorite thing to design, my bread and butter, if you will. So definitely going to be doing more wheels throughout, more car related stuff, more camera related stuff. Those are two of my like big interests. And then hopefully some other fun things will come along. And then probably some gaming on the weekends if people want to see me play games badly, because I'm not amazing at it, but I play Arena Breakout Infinite, I play the finals, I play Arc Raiders, I play Stalker, stuff like that. And we could play some other games, like whatever you guys want. So yeah, I think this is probably about where I'll cut this first stream off. Just pull up this final image here. Beep boop, beep boop, beep boop. Even the fastest computer can't process just the organization of files. Okay, so here's this final render that I walked you guys through and we did together. I think it came out really great. Looks pretty photorealistic, and hopefully doing some more in-depth design stuff next time. Yeah.